Good evening, sir. சார்
எஸ் யுவராஜ்.
சார் அது டவுன்லோட் பண்ண ட்ரை பண்ணியும் ஒர்க் ஆக மாட்டேங்குது சார். ஸ்க்ரீன் ஷேர் பண்றேன், இப்போ ஆகுதா பாக்குறீங்களா? ஷேர்
ஓகே.
ஆகுதா?
நான் வேற வெர்ஷன் டவுன்லோட் பண்ண சொன்னேன்ல, அதுவுமே ஆகலையா?
அது பண்ணியும் ஒர்க் ஆகல சார். அதே இஷ்யூ வந்தது. நான் என்ன பண்ணேன், திரும்பியும் பழைய வெர்ஷனையே இன்ஸ்டால் பண்ணிட்டு செக் ஃபார் அப்டேட்ஸ் கொடுத்தேன். அப்போ
ஓகே.
வந்து ஒரு எரர் ஒன்று காமிச்சிச்சு. ஸ்கிரீன்ஷாட் எடுத்து வச்சுக்கோங்க ஒரு நிமிஷம்.
சரி, ஓகே.
ஸ்கிரீன்ஷாட் பண்றேன் சார்.
ஓகே.
விசிபிளா இருக்கா சார்?
ஓகே. அன்ஏபிள் டு ரீட் ரெபாசிட்டரி, அன்ஏபிள் டு ரீட் ரெபாசிட்டரி. ஓகே, இது நெட்வொர்க் இஷ்யூ தான்.
ஓகே.
இது வந்து ஓகே. இதை க்ளோஸ் பண்ணுறேங்க ஒரு நிமிஷம்.
நான் அப்புறமும் அதுக்கப்புறம் ஓகே கொடுத்தேன் சார். ஸோ இந்த
அது
மாதிரி ரன்
ஓகே.
ஆயிட்டு இருக்கு சார். கீழே ரன் ஆயிட்டு இருக்கு இது மாதிரி.
சரி, ஓகே. அது ஆக்சுவலி நெட்வொர்க் இஷ்யூ தான். நெட்வொர்க் ஸ்லோவாக இருந்துச்சு அப்படின்னா அந்த எரர் வரும்.
ஸோ இந்த வாட்டி அப்டேட் ஆயிடுச்சுன்னா கரெக்டாக ஆயிடும்ன்றீங்களா?
ஆகணும். ஆக்சுவலாக
அதாலேயே
இந்த இஷ்யூ வந்து சிஸ்டம் ரிலேட்டட் இஷ்யூ தான். உங்களோட பிசியில் இருக்கக்கூடிய இஷ்யூ. ஓகேங்களா? இது ஜென்ரல் இஷ்யூவாக இருந்தால் நம்ம ஏதாச்சும் சொல்யூஷன் ஃபோரமில் தேடி பார்க்கலாம். இது சிஸ்டம் ரிலேட்டட் இஷ்யூ அப்படின்றதுனால நம்ம சிஸ்டமில் என்ன ப்ராப்ளம் இருக்குன்றதை பார்த்து தான் ரெக்டிஃபை பண்ண முடியும்.
இப்போ நான் திரும்பியும் சி டிரைவ் டி டிரைவ் தனித்தனியா மேக் பண்ணா அப்போ ஏதாவது ப்ராப்ளம் வருமா சார்? அது
அப்படி எதுவும் ஆகாது.
அப்பவும் பண்ணலாம் இல்லைங்களா?
அப்படியே பண்ணலாம்.
ஓகே.
சரி.
சரி சார், செக் பண்ணிட்டு சார்.
ஓகே, ஓகே.
சார்
சொல்லுங்க விராஜ்.
சார் அந்த அப்டேட் முடிஞ்சதுக்கு அப்புறம் அந்த ட்ரஸ்ட்னு சொல்லிட்டு ஒரு பேஜ் ஓப்பன் ஆச்சு சார்.
அது கொடுக்கணும்.
செலக்ட் ஆல் கொடுத்துறீங்களா?
ஆமா.
ட்ரஸ்ட் செலக்டட். அப்டேட் ஆகுது சார், ஃபாஸ்டா அப்டேட் ஆகுது. ரீஸ்டார்ட் டு அப்ளை த சாஃப்ட்வேர் அப்டேட்.
ஆமா,
ரீஸ்டார்ட்
restart.
கொடுத்துருங்க.
Mohammed, is that problem solved for you? That IOC file?
I have to check, sir.
Okay. Nice.
சேம் ஒர்க் ஸ்பேஸே கொடுத்தா இல்ல சேஞ்ச் பண்றா சார்?
வேற ஒர்க் ஸ்பேஸ் கொடுத்து பாருங்க.
அந்த அந்த ஃபோல்டர்லயே வேற வெர்ஷன் கொடுத்துட்டா இல்ல?
அந்த ஃபோல்டர்லயே வேற ஃபோல்டர் கிரியேட் பண்ணாலும் ஓகே.
Hi, sir.
Hi Arvind.
So actually, I have tried yesterday and day before day on my local PC. Like, so the RTOS, all the programming. What happened
Okay.
suddenly? The serial wire viewer actually, I was getting output frequently. Like I was, but suddenly that LED is blinking, but serial wire viewer is not getting. I tried closing that console and again opening, but
Okay.
no, I'm not getting.
You are not getting in the sense, is it a blank?
Yeah,
blank output.
Yes.
Okay.
Not getting in the sense that configuration tool, if I select it, is not showing that port 0, but already port 0 was showing, but I
Okay.
click that configuration tab, that it is not working. It's not even open that showing that port available on all the port and
Okay, just confirm me the steps what I'm saying. Have you copied and pasted the ITM code in syscall?
Yes, sir. Yes.
Okay. So while debugging, have you enabled the serial wire viewer? In project, you are just doing right click, debug as STM32C C++, right?
No,
in the
sir.
debugger,
I think I missed that. Yes.
Okay, you need to enable that serial wire viewer
Okay, sir.
in the debugger. Okay.
Yeah.
Yeah. And also one more thing, Arvind, I just wanted to ask you this. Just a minute, I'll share the screen. So this is for the student progress. Okay. So you are yet to provide your GitHub link to me.
Okay, sir. I'll provide by today.
Yeah, because tomorrow I will send you the projects for these 4 things. C++, bare metal, device driver, and RTOS. So you need to upload these projects in that GitHub only. Okay.
Okay.
So just create it and send me. I'll just put it over here.
Sure.
Certificate given. Okay. And also, Venkat, you also need to submit the project link.
Yes, sir. Okay.
And you have to upload your C project also. I think you haven't uploaded that. So create a GitHub and upload the C project.
Yeah, already I have created, but it's showing something error.
Okay.
That's why I contact you.
Okay. Yeah. Long back you called me, right? Okay.
Yeah,
Is the problem resolved?
No, sir.
Okay.
I will do again and contact you again.
Yeah, sure.
Okay, sir.
Okay.
Sir, I have some network issues. I will.
Okay. And Mohammed, you're also not submitted your C project, I think, right? In your GitHub. Yes, you're given the link, but you have yet to upload.
Yes, I have to. Still, I have not started, sir.
Okay. So finish it by this week. This week we will allocate entirely for the project. So
Okay.
if you have any doubt, you can join in this session and you can clarify. I'll be available from 7 to 9, same timing. You can join and clear the doubts, whatever you have.
Okay,
Yeah.
like you will be available online on
Yeah,
this
online
link.
I'll be available in the same
Okay.
link.
Okay, fine. Sir.
Okay, so we'll start today's class. So the last topic of your free RTOS is the mutex. Okay. Okay, so last class we discussed about the synchronization between multiple tasks in the free RTOS, right? And the one more synchronization that is available in free RTOS is the mutex. Okay, so today we are going to see the mutex. Okay, so mutex, is the screen visible? Okay.
Yes, sir.
Yeah. So mutex, the expansion of mutex is it's a mutual exclusion. Okay, as this is also used for synchronization between the multiple tasks, but specifically the semaphore is actually used for the entire synchronization between multiple tasks. Like you want to execute any task in particular order, then you will be using the synchronization. And mutex will be used mostly for the shared resources. Okay, so whenever there is any shared resources available in your project or in your applications, then we'll be using this mutex. Okay. Now, the shared resource is nothing but like, let's say, okay. Imagine you are having a common printer. Okay, and this printer is connected to multiple PCs. Let's say this is PC1, PC2, PC3, and PC4. Okay. And now what I'm doing is initially I'm printing one document from PC1. I'm sending a printing request from this PC1. Now the printer is printing. So this document is containing, let's say, 50 pages. Okay, and I'm sending this request. Your printer is printing those documents over here. Okay, now when it is printing somewhere around, let's say, 30 pages. Okay, so now what I'm doing is I'm just sending in another request from PC3. Okay, of some 10 pages. Okay, what will happen? It is currently printing at 50 pages and you are in the 30th page. Okay, and PC3 is printing or giving a request of 10 pages of printing. What it will do?
So first it will complete 50, then it will take.
Yeah.
Go
No,
for
it will
10.
be like overlap that.
Overlap in the sense?
Like the 50 pages means like at what pages it is reading. From that it will read.
No, it's printing 30th page. Okay, now I'm giving it 10 pages request.
30. Yeah, 30.
Okay.
From the 30 it will print.
From 30 to
40. I mean 30 to 40. It will.
why 40? See, this is an different 50 pages and this is different 10 pages.
Okay.
Okay. So now what will happen? Is the question clear?
No,
See,
I'm not getting.
okay, there are two documents. Okay, One document is 50 pages. One document is 10 pages. Okay, both are different documents. Now PC1 is printing or giving this control P and printing a 50-page document. Okay, so this printer is printing each and every page, and when it is reaching the 30th page, what is happening is PC3 is printing another document that is different from this 50 pages. Okay, the size of that document is a 10-page document. Okay, now what will happen in your printer? Will it completely print all 50 pages and then go to this 10 pages, or in between this 30th page, will it start printing the 10 pages also?
It will
Complete
the
the 50 pages and then
Ah,
continue the
okay,
10
so
pages.
it will complete the 50 pages and then it will go to the new document. Okay, even though this document has only 10 pages and there are 20 pages left in this document, okay, it will not go and print this 10 pages and then will come back. It will completely print this one and then it will print the 10 pages. Okay, and when it is printing this 20 pages, if another request comes, what will happen? Once it completely prints 50 pages, it will go to the 10 page and then this will go to the next request. Okay, now here this printer is the shared resource. Okay, this resource we are sharing between multiple PCs. Okay, similarly, we'll just take this into our electronics. Like, let's say I'm having a memory, let's say EEPROM. Okay, so I'm having an EEPROM, and in this EEPROM, I'm just connecting multiple devices, multiple sensors, let's say. Okay, or let's say this is my microcontroller, this is my DMA, okay, and this is my interrupt. Okay, all three want to access this EEPROM or show storing the data or retrieving the data. Okay, both the things has to done from this EEPROM between these devices. Okay, now what will happen? Initially, if this microcontroller is giving or asking any data to be transferred, it has to transfer through this data. Okay, and suddenly if DMA is accessing means or DMA is asking any permission, it has to wait for completion of this transmission to this microcontroller and then it will go to the DMA. Okay, so this is my shared resource or shared memory. Okay, so now what will happen is whenever we are working with the parallel processing or multi-threading, in some applications we may require to access the same resource. Okay, during that time, see, your microcontroller is accessing a particular memory. During that time, your DMA is also trying to access, means what will happen? There will be some data corrupt occurs in this EEPROM. Okay, so in order to avoid the data corrupt, we will be finished transferring all this data to this microcontroller and then we will attend the next request, whatever the request comes from any peripheral device. Okay, so this is what and shared resources, and this is actually has to be happen in the synchronization. First microcontroller, then DMA, and after DMA, if there is any other request comes, then it has to go and attend that particular request. Okay, so whenever we are dealing with any particular shared resource, we will be using this mutex, mutual exclusion. Okay, it is again a same key or a token method as like your semaphore. Okay, so when whichever task has to access this shared resource, it has to take the key. First, it has to take the key. It has to do all this process and then it has to return the key back. And the next task again, it will ask take and it will return. And then next other task, if it is giving any request, then it will take and return. Okay, so this is like your semaphore key take and key give, like same concept. We will be having a key or a token method. This mutex is otherwise called as the binary semaphore. What is binary semaphore? What is binary semaphore?
Mutex.
No, I'm just asking what is the working of binary semaphore? Last class we saw binary semaphore and counting semaphore, right? What is binary semaphore? How many keys it is having?
2 actually.
2.
1.
Okay, it is having only one key.
1.
Okay.
Lock and unlock.
Yeah, lock and unlock or take and give, right? So similarly, mutex is having only one key. Okay, you have to take the key, you have to do the process, and you have to return the key back. Only then the next task will take that key and it will return or it will do the process. Okay, or else this DMA will never execute until this microcontroller returns the key. Okay, so that is what and mutex is. Mutex will work based on the semaphore only. Okay, so mutex is similar to that of your binary semaphore. Okay, so all the APIs we are using in our mutex is based on the semaphore APIs only. Okay, I'll just show you what it is. Okay, so here it is semaphore and mutex. Like if you want to create a mutex, okay, you just have to use this X semaphore create and the semaphore take and semaphore give. So we'll be using the 3 APIs as usual. First one is for creating the binary semaphore, we'll be using X semaphore create binary. For creating a counting semaphore, we'll be using X semaphore create counting. Okay, similarly, for creating a mutex, we'll be using X semaphore create mutex. Okay, since mutex is an as like your binary semaphore, there are no parameters here. We just have to give the void. Okay, there is no parameter inside the create mutex. And for taking the key, same thing like X semaphore take, which semaphore you have to take the key and what is the time take you need to wait. Okay, and similarly for give also the same thing like which semaphore I have to give the key back. Okay, so this is same as your semaphore, binary semaphore. The only difference is whenever we are creating a mutex, we just have to give something like an X semaphore create mutex. Okay, so that is the only change you have to do with this one. Okay, now we will create a project. So RTOS Okay, so next I'm just going to close this one on the old project. Okay, I'm going to create a new project STM32. System is small. So in board selector, I'm just going to select the STM32. Next, this is mutex. Okay, so I'm just going to leave it as it is. Now I'll open the free RTOS kernel. I just paste it here. Right click, exclude, and right click again, properties, C++ settings, include path, workspace, text. It is CM4 include memory management. Okay. Yeah, after that I'm just going to this RCC bypass crystal ceramic timer 3 and in NVIC code generation, sysdig, pendable, and system service. Okay, I'm just going to build this. Okay. So configuration part is done. Now I'm just going to write the code for mutex also. Since we are using in semaphore APIs, okay, for creating the mutex, you just need to use semaphore.h header file. Okay, as like how we did in our last class, the same thing. Okay, so I'm just going to create. Just maximize this. Okay, so I'm just going to create hash include. First one is free RTOS and hash include task.h hash include. I'm just going to use in semaphore. So this is semaphore.h and hash include stdio for the printf statement. Okay, so for printf statement, I forgot to copy and paste the ITM code. So I'll just copy and paste it. So go src syscall. Here I'm going to paste it. ITM sendcar copy and I'll paste it here. Okay, these things we already did on all the classes. Okay, I'm just skipping this. Okay. Now I've created the header files for all the modules which I'm going to use here. Free RTOS task I'm going to use, semaphore I'm going to use. Okay. Now inside this private variable, as like your semaphore creation, we have used the handle, right? Similarly for mutex also, I need to create an handle. Okay. So we don't have a separate handle for the mutex. Okay. We are going to use a semaphore handle only. So semaphore handle underscore t. I'm just going to give something like let's say mutex 1. Okay. So this is my handle. By using this handle, I'm just going to create an mutex. Okay. So in user code begin to mutex1 equal to x semaphore create mutex. Okay, so last class we saw the create binary and create counting. So now we are going to create the mutex. Okay, so it doesn't have any parameters since it is an binary semaphore kind of thing. We don't have any parameters or arguments inside that one. Okay. Now, if this mutex 1 is not equal to null, okay, that means I'm just going to put a printf statement saying mutex created successfully. /r/. Okay, that means if it is not returning the null, it is created. Okay, so I'm just printing mutex is created successfully. Okay, so once it is created successfully, what I'm going to do, I'm just going to create two different tasks. Okay, so first one is X task create. Okay, let's say this is my first task. This is my task number 1, and depth is 200, parameter is null, and the priority is, okay, it can be anything, so I'm just giving 3, and this is also null. Okay, I'm just going to copy this. This is for the second task also. Okay, so this is second task, and this is task number 2. I'm just going to leave the same sorry. Yeah, I'm just going to leave the same priority for both these things. Okay, as a 3 and 3. Okay, next I'm just going to give vtask start scheduler for creating the scheduler for these two tasks. Okay, now I just need to do this function, right? So I'll just go to the user code 4. Here I'm just going to create a function with the void pointer. So inside this, I'm just going to give while of 1. Okay. So inside while of 1, since mutex means we are going to use for the shared resource, right? Here we don't have any shared resource. So what I'm going to do, let's say, okay, I'm just going to give a private variable where it is. Yeah, here we have private variable, right? I'm just going to give something like int shared resource. Okay, initially make it as 0. In real time, what will happen? There might be any shared resources. It can be your internal EEPROM memory, or it can be some peripheral devices. Okay, like your communication device, like what we saw in our device driver module, the same thing. Okay, it can be anything. Here we don't have all these things, right? So I'm just giving for an example. We'll be using this variable as a shared resource. Okay. Now what I'm going to do, sorry, I'm just going to copy this here in a printf statement. Okay, let's say I'm just going to do the plus plus. Okay, in first task. Wait, initially it will go to task number 2. Okay, I'm just going to do the minus minus here. I'm just going to do the printf statement. The shared resource value in task 1 is, I'll just put a %d, comma, shared resource. Okay, let's make this as /r/n for printing in the new line. Okay, so I'm just going to copy this thing and I'll paste it here. Okay, so let's make this as a second task. And here I'm just going to give shared resource plus plus. Okay, so this is my task number 2. So what I'm planning is, initially my shared resource is 0, right? Okay, my task number 2 will execute first. Since both have same priority, task number 2 will execute first. I'm just going to increment the shared resource. So I'll be getting 1 here. Okay, and it will preempt to task number 1. I'm just going to decrement this. So again, it will become 0. Okay, it has to print. Again, it has to go here and it will be 1. It will be 0. So it will be 1. It will be 0. So when we are accessing the shared resource in the synchronization method, you will be getting 10 10 10 10 as an output. Okay, in task number 2 it has to be 1, and task number 1 it has to be 0. But in real time, without this mutex, it will not happen synchronously. Okay, first we will execute without the synchronization and we'll see what is happening. Okay, and then we will give the synchronization after that. That is your mutex after that. Okay, private function prototype. I'm just going to declare this functions as first task and second task. This is first task and this is second task. Okay, nice. So I'm just going to build this one and yeah, there is 0 errors and warning. Okay, so I'm going to connect my board. So build and I'm just going to right click this, debug as STM32. Now in this debugger, I'm just going to enable the serial wire viewer. Okay, so this I have to give enable and then OK. Switch. Okay, inside the serial wire viewer data configuration port 0 and I'm going to start the trace. Okay, so my expected output is it has to be 101010 has to be printed. Okay, task 2, task 1, task 2, task 1. In task 2 it has to be 1 and in task 1 it has to be 0. Okay, that is what my expected output. Without synchronization, what we will get is, I'll just suspend this, I'll copy and I'll paste it in the notepad. Okay, you can see initially the shared resource value is 1 and 0, 1 and 0. Again, it is 0, it is 0 again, it is -1, -1, 1, -1, -1, -2, okay, -2, -3. Okay, so I'm getting a -4, -2. And again, here I'm just getting 0, 1, 0, 1, 0, 1 and all these things. Here I'm just getting 1, 2, 3 something. Okay, so here I'm getting even 6, 5 and all. Okay, that means, yeah, oh, sorry, 8, 9 and 10, all these things are going. Okay, so what is happening is it is not executing synchronously. Okay, so some task is executing for more than one cycle and some task is executing after some 3 or 4 cycles. So that means it is keep on incrementing or keep on decrementing. Okay, so that is what happened without the synchronization. Now, if it is happen in the real time, what will happen? The memory will get corrupt. Like I need to access, let's take the same printer as an example, what I said. Okay, so now instead of printing this 50 pages entirely, what it will happen is it is printing the 30 pages, right? 31st page, it will take from this 10-page document. Okay, again 32nd page, it will take from this 50-page document. Okay, again this will be from 10 page, 50 page. So it will just mingle instead of printing a 50 page alone and 10 page alone. Okay, so instead of printing this separately, it will just mingle in the shared resource. Similarly for the EEPROM. Okay, instead of executing this microcontroller memory completely, what will happen? This memory will be corrupted with this DMA memory. Okay, so that is what actually happening here with the shared resource variable name. Okay, now how to avoid this? We need to avoid this by giving the key or a token method in the mutex. Okay, so I'm just going to take this where it is. Yeah, here I'm just going to give X semaphore take. Okay, so it is asking which semaphore I need to take and what is the block type. So semaphore name is mutex 1 And the block time, I'm just going to give it as an port max delay. Okay, maximum delay period, hold it. I'll be returning it manually. Okay, so after that, I'll be just giving X semaphore give. Okay, it is asking which semaphore, the same mutex. Okay, similarly, here I'll just put one thing and here I'll put another thing. Okay, so after this, I'm just going to give the task delay of something like, let's say 1. So debug data console. If I run this, I'm just going to copy and paste. Now you can see mutex created successfully. Then 1 0 1 0 1 0 1 0 1 0. Okay, it is executing synchronously. Okay, that means task 1, sorry, task 2, task 1, task 2, task 1, task 2, task 1. The shared resource is accessible by synchronization method. Okay, so first it will increment it, and then it will left, it will decrement it, and then it will left. Again it will increment, again it will decrement. Okay, so we are actually implemented the synchronization of task by using this mutex. Okay, with an token or a key method. Okay, so this is how we'll be accessing our shared resource. Any shared resource, it can be a peripheral device or it can be a memory. Okay, we'll be using this semaphore mutex method. Okay, for making this task execute synchronously. Okay, so this is not only for the 2 tasks. Even if you have some like a 5 or a 10 tasks, any multiple number of tasks, you can easily able to take and give this key, and we can able to execute this. Okay, so that is what unmutex is. Clear? Any doubts?
No.
Okay. Yeah, so copy this code.
Sir, scroll down, sir.
Scroll down.
Sir, scroll down, sir. Sir, scroll down, sir.
Finished. Go to output.
Sir, one second. Can I share my screen, sir? One second.
Yeah, sure.
Yeah, it's visible, sir.
Yes.
Is it visible, sir?
Yes, Evan, it's visible.
Yeah. So
Just scroll
actually,
down.
here only. Okay, sir. Oh,
Yeah.
this
Enable that one.
Okay.
Click OK. No, it will automatically do. No need to do that. Yeah. Switch. Okay. Click configure.
Now it's up.
Port 0. Yeah. Start trace. No. You have to start trace. Okay. Now click that. Okay.
Okay, sir. Thank you.
Yeah. Thanks.
Sir, I'm not getting output.
What happened? Any errors?
No, not errors. I'm sharing my screen.
Yeah, sure. Field within the API. Okay. Just click suspend. Okay. Go to main function. Scroll down. Okay. Open that syscall.c. It's in src. Yeah. Okay. Yeah, you haven't copy and paste it.
Oh, okay.
File. Okay. Yes.
Sir, one help, sir. So
Yes.
while writing code, I'm not getting that suggestions, sir. Like
For that, you are giving this header file, right? Once you give that
Okay,
header
sir.
file, you just have to either save this file or you have to build it. Then only that header files will be added to .c. Okay.
Okay.
Yeah. Can you just type now? You already executed it once, right? Just type something like X task and then give control space. You will get now.
Okay, sir. Let me try. Yes, sir. Now I get.
Yeah. So that is the thing. So after giving that header file, either save that or build it. Okay. So that it will add it to your file. Okay. So this
Sir,
is
one
the
more, like keep on printing this print. What happened? Yeah, like some more runs. After some more runs, so like it's showing something is full.
buffer is full.
Some buffer is full.
Yeah.
Then it automatically exit.
Yes, it will automatically execute. See, what we are doing is we are not actually seeing the real-time output. Okay. What is this ITM means? Your data will transfer through the serial wire viewer. Okay. We are giving this ITM code to capture the data and we are just printing it in the printf statement. Right? That is something like a buffer. We are just tapping that output and we are just taking an copy of that exact output and we are printing in the printf statement. Okay. So after some time that ITM buffer will get full. But your code is keep on printing in the background, but only this ITM buffer is full, so it will just exit.
Okay.
Yeah. You can just click that clear button. I'll show you where it is. If it shows this ITM is full, there is this X mark over here, right? Okay, that is a clear output. Okay, you can just press that. It will clear all the outputs in this console and it will just start printing again. This X mark.
Okay. Okay. Got it.
Yeah.
Sir, can
Okay.
you show me second task function?
Second task in this one. Wait, I'll maximize.
Actually, I'm getting output like first it will show task 2, then task 1 only it is showing.
Yeah, first it will execute task 2 only.
But it is continuously showing task 1 only, while yours are like -1, -2, -3.
Have you given betas delay on both the tasks? With the same delay time?
No, okay. In first task 1, I have given 1 only.
Done.
Okay, sir, done now, sir.
Okay. So this is what the mutex is. Okay. And in mutex, what will happen whenever we are dealing with multiple tasks or multiple, not multiple tasks, the multiple mutexes. Okay. So here we are using only one mutex, right? Like something like a mutex 1. This mutex 1 has one key. We'll be taking that key and we are returning the key back. Okay. Imagine in some of the application, we'll be using multiple mutex. Okay. And whenever we are using this multiple mutex to access the shared resource, there might be, you will get something like a deadlock mutex can occur. Okay. So there is something called as a deadlock mutex.
I thought to ask about this.
Okay. So this deadlock mutex is, for example, if you are having two tasks, each task is getting one mutex respectively. Okay. And for taking the other mutex key, it has to release the key which is currently holding. Okay. I'll show you an example. During that time, what will happen? Neither of the tasks can be able to return the key back until it is taking the key from the other task. Okay. So there occurs something called as a deadlock. Okay. So none of the tasks will get executed after one time. For example, let's say you are having something like a mutex number 1 and mutex number 2. There are two mutexes. Okay. And you are having task number 1 and task number 2. Okay. So initially what happens? Task number 1 is taking mutex number 1 and task number 2 is taking mutex number 2. Okay. Now it has to release or give mutex number 1, right? And similarly, it has to give mutex number 2. Okay, this is what our routine is. But what it is asking is, it is trying to take the mutex number 2 to give mutex number 1. Okay, and similarly in task number 2, it is trying to take the mutex number 1 in order to release the mutex number 2. Okay, this is what I have written the code. Imagine like that. Now what happens? First, I am taking the key of mutex 1. Okay, inside this, I'm just executing something. Now I'm trying to take this mutex number 2, but mutex number 2 is available in the task number 2. Okay, now I'm waiting for a few times. Okay, let this task number 2 release the key so that I can able to take it and I will return the mutex number 1, which I'm currently holding. Okay, but in task number 2, what is happening? In order to release this mutex number 2, I need to take the mutex number 1, which is available in the task number 1. So neither of this task will return the key back until it is taking that key which is holding in the previous task, right? So there comes the deadlock. Okay, this can't able to take the mutex from the other task, okay, in order to release the key. So it will execute only once. This will execute once and this will execute once, and then there will be a deadlock. Both the tasks will stuck for an infinite amount of time. Okay, so this is what called as a deadlock mutex. So you need to avoid this deadlock mutex in your code. Okay, so whenever you are writing or whenever you are dealing with multiple mutexes, you need to make sure that none of the key is logged in another task. Okay, so that we need to check. Okay, I'll just give one example for this deadlock mutex. Is it clear what this deadlock mutex is in theory?
Yes, sir.
Yeah. So I'm just okay, so I'm just going to close this mutex project. Okay, I'll paste in the deadlock. Right click, properties, CC++ build, exclude resource, apply and close. Again, right click, this properties, settings, include path, add workspace, deadlock. Okay, apply and close. And then here RCC, I'll just bypass. I'll just use this crystal ceramic, timer 3, NVIC, code generation, these 3. And similarly, we need to open the ITM. Copy. Okay, so it's 0 errors and warning. I'm going to start writing the code. So initially the same include files. Free RTOS.h, hash include task.h, hash include semaphore.h, scmph. Okay, hash include stdio.h. Okay, so after that, I'm just going to click build. So 0 errors and warning. Now I'm just going to start writing the code for the mutexes. Okay, let's say I'm going to create 2 different mutex. both are semaphore handles. Let's say this is mutex number 1. Okay. And this is mutex number 2. There are 2 different mutexes. Okay. So initially what I'm going to do is I'm just going to create 2 different mutexes in this user code begin 2. I'm just going to give mutex 1, right? So mutex 1, which is equal to x semaphore mutex. Sorry, create mutex. Okay, this is one thing. And the next one is mutex number 2. Okay, so I've created 2 different mutexes, mutex number 1 and mutex number 2. Okay, now in this, what I'm going to do is I'm just going to create a task. Okay, usually what we will do, we will create a 2 different tasks at the same place, right? Instead of that, I'm just going to create only one task here. Let's say this is task number 1, and this is my task number 1 here, and this is null. Sorry, this is my 200, and this is my null. And let's say the priority of this one is 1. I'll tell you why. I'm just giving the least priority for this. Okay. After that, I'm just giving v task start scheduler. Okay. Now, okay. V task start scheduler. Okay, I've given that. Now I need to write the code for this task number 1, right? Okay. This is what I need to do. I have only one task. So what will happen? Your scheduler will always pick that task irrespective of that, the priority. Okay, we have only one task. So your scheduler will take only that task and it will start executing. Okay, sorry. This is task number 1, I think so. So void task number 1. Instead of that, inside that I'll give void pointer. Okay, so inside while of, I'll just type it here. Inside while of 1, I'm just going to give first, let's say, okay. First, we will take the semaphore of x semaphore take, right? X semaphore take. Okay, I'm going to take the mutex number 1 for the port max delay type. Okay, so initially I have taken the key number 1. Okay, so before that, what I will do, I will just put a printf statement so that we will know taking mutex 1. Okay, this is what I'm printing. Let's say I'm just printing it 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, /r/n. So I'm printing taking mutex number 1, and I have taken that mutex number 1. Okay, that is done. After that, once I have taken this mutex number 1, here I'm just going to give x task create. Okay, inside this, I'm going to create the task number 2 with the highest priority. Okay, so I'm just giving null. Sorry, this is not null. This is my 200, and this is my null. And priority is I am giving, let's say 4. Okay, and null. Now what happens? Your task number 1 is having a priority of 1, right? Okay, now inside this task number 1, we are creating another task which has an highest priority. Now this task will be available in your ready state, right? Okay, now your scheduler will see, okay, this has an highest priority. We need to execute it. Okay, so it will stop here itself and it will go to task number 2. Okay, I'll just write a task number 2 and then I'll come back here, what it will do. So your scheduler will go to task number 2. Here I'm just giving void task number 2 of void pointer. Okay, inside this, I'm just giving while of 1. Okay, I'm just printing the same thing. Sorry, I need to give a semicolon here. Okay, I'm just printing the, okay, both the same thing. One is for taking mutex number 2. Instead of star, I'm just giving something else like equal to. Okay, this is mutex number 2. Okay, so I'll just tell you the steps what it will execute. First, it will come inside task number 1 because that is the only thing available. So after that, it is printing taking mutex number 1 and I'm taking the mutex number 1. After that, I have created the task number 2, which has an highest priority. So this will available in your ready state. Your scheduler will preempt this task number 2 with this task number 1. Okay, it will directly go over here. And here I'm just printing taking mutex number 2. And then I'm just printing this. Okay, I'm just taking the mutex number 2. After this, what I'm doing is I'm just printing this one. Okay, I'll just print attempting to take mutex number 1. Okay, I'm trying to take mutex number 1 here. Okay, after taking this mutex number 1, I am planning to give mutex number 2. You should not write like this. I'm just telling what this deadlock mutex is. Okay. Now, similarly, this one is trying to take the mutex number 2. Okay, attempting to take mutex number 2. Let's mark it as star for seeing the difference. Okay, so I'm trying to take mutex number 2. And after taking it, I'm trying to release the mutex number 1. Okay, I'll tell you the step what it is executing in order. I'll just give something like a VTAS delay so that we know it is switching off, something like I'm just giving 1. Okay, I'll tell you the step. First, it will come inside this line number 171. It will print taking mutex number 1. It will take mutex number 1. So now mutex number 1 is available in task number 1. Okay. After that, I am creating task number 2 with an high priority and it will just jump to line number 185. Okay. Here I'm just printing taking mutex number 2 and I have taken the mutex number 2 for a maximum delay time. And inside this task number 2, I am attempting to take the mutex number 1. So I'm trying to take mutex number 1, but mutex number 1 is available in task number 1. Okay, so it will wait in line number 192 and then it will preempt to this one. Okay, where it is preempt, it will preempt to this one, attempting to take mutex number 2. Here I'm trying to take mutex number 2, but that is available in the task number 2. Okay, so when this will give, after taking this line, I will give this. But when I will take this one after taking the mutex number 2, I will give the mutex number 1. Okay, so both the keys are logged in their respective task. In order to remove that or in order to give that, it has to take the other task key. Okay, so this is what called as a deadlock mutex. It will print or it will execute only once. After that, it will be stuck in that task. Okay, so that is what called as a deadlock mutex. We will see how it is happening. So this is task number 1. This is task number 2. Okay, I'm just going to build this one. 0 errors and warning. I'm just going to right click, debug as STM32. Debugger, enable. Okay. Switch. Now I'm just going to make this port 0 enabled. And here I'm just giving the start trace. Okay, now you can see if I click resume, okay, it will stop there. First it is, okay, I'll just copy this and I'll paste in the notepad. You can see, you can see first it is taking mutex number 1. After that it is taking mutex number 2. And inside task number 2, I'm just trying to take mutex number 1, but mutex number 1 is available in task number 1, right? So it will go there and it will try to take the mutex number 2 in order to release the mutex number 1. So both will get stuck. Okay, so this is what called as deadlock mutex. Okay, you should be aware whenever we are dealing with multiple mutexes in your application, we need to make sure that none of the key is available or stuck inside the other key. Okay, so this is what called as a deadlock mutex. Clear?
Yes, sir.
Okay, so copy this code. This is same header file. Okay, start writing from here.
How we can avoid it, sir? Is there any timer we can give?
See, the only way we can avoid is don't
User
give.
has to manually.
We have to check this manually. We should not take and give the key like this. Okay, in order to give the, if you give something like this, or let's say, just put this over here, it will work fine. Okay, we are giving the key and then we are taking the another key. Okay, now this
Yes.
deadlock will be avoided. Okay, you should not put something like first take the key and then release it back. You should not give something like that. Okay, so it will not work. So we need to manually avoid it. Or don't give this port max delay. Okay, so if you know the time period of executing the statement, give that time period over here. For example, if you know this printf statement will take something like an 10 ticks to execute. Okay, just give 10. So that after 10 ticks, this key will be automatically released. Okay, there is no need to give this give. Okay, even if you delete this key will be released after 10 ticks. So either manually we just have to give that. It's not open. Okay. Okay, either you just have to give that manually or just don't give the port max delay. This is mutex number 2. Okay. Yeah. So start writing this one.
Sir, scroll down, sir.
Yes, Mohammed.
Scroll down, sir.
Okay, others, can I scroll down? Okay.
Sir, scroll down. Sir, scroll down, sir. Sir, scroll down, sir.
Miss scroll down.
Yes, sir.
Yes, sir. Sir, scroll down, sir.
So can you show the last 2 line of task? Just little, yeah, okay.
Finished? Got output?
Yes, sir.
Okay. Arvind?
Yes, sir. Right.
Okay. Yoraj, what happened? Is it opening? The new version.
நோ நோ சார்
இப்போ என்ன?
ஆஃப்டர் அதே தான் சார் இப்போ அப்டேட் ஆயிடுச்சு 1.19 வந்துச்சு
ஓகே.
திரும்பியும் ஆன் பண்ண உடனே ஓப்பன் ஆயிட்டு அப்டேட் க்ளோஸ் ஆயிடுச்சு சார்
இது
நான்
சிஸ்டம் இஷ்யூ தான்.
ஸ்கேன் பண்ணிட்டு ஷேர் பண்றீங்களா
ஓகே.
அதுதான் இது இப்போ ஆன்லைன் அப்பாயின்மெண்ட் தான் போட்டிருக்கேன் அவங்க என்ன சொல்றாங்கன்னா நான் இன்னைக்கு எடுத்துட்டு போய் கொடுத்தேன் சர்வீஸ் சென்டர்ல
ம்.
அவங்க வந்து 7 நாள் ஆகும்னு சொல்றாங்க சார் கிளியர் பண்றது
ஓ.
ஸோ அதான் சரி இதோ இது அப்டேட் ஆயிடுச்சு ஆக்சுவலா ஈவன் வேற ஒரு கிரியேட் பண்ணியிருந்தேன் இது ஒர்க் ஸ்பேஸ் ஒன்று கிரியேட் பண்ணேன்
ஓகே.
ஸோ அது செலக்ட் பண்ணிட்டு
ஓகே தான். அது இல்லை தான். ஓகே. லான்ச்.
கரெக்ட் தானே
கரெக்ட் தான், கரெக்ட் தான்.
லான்ச் பண்ணோம் இது ஓப்பன் ஆகும்
ஓகே. இந்த இன்ஃபர்மேஷன் சென்டர் க்ளோஸ் பண்ணிடுங்க.
இப்போ நியூ
File.
ப்ராஜெக்ட் கொடுப்பேன்
நியூ STM32 ப்ராஜெக்ட். ஓகே.
இது கேட்கும் ஸோ ஃபர்ஸ்ட் நான் இது கொடுத்தேன் பாருங்க எதுவுமே பண்ணலையா அப்டேட்னு கேட்டு ரெக்வஸ்ட்
சரி, மறுபடியும் ஓப்பன் பண்ணுங்க.
பேக்ரவுண்ட் ரன் பண்ணல நானும்
ஓகே,
பேக்ரவுண்ட்
ஓகே.
செக் பண்ணி பார்த்தேன் அங்கேயும் ரன் ஆகல
சரி, ஒரே நிமிஷம். அது அப்டேட் ஒரு நிமிஷம். லான்ச்.
வெர்ஷன் மாறிச்சு பார்த்தீங்களா 1.1
அது ஓகே. மேக்ஸிமைஸ் ஃபைல் நியூ STM32.
அவ்வளோதான் இது மாதிரி வருது அந்த க்ளோஸ் ஆகுது அது லோட் ஆக மாட்டேங்குதா இல்ல வேற என்ன ப்ராப்ளம் தெரியல ஆக்சுவலா ஆனா ஸ்பேஸ் இருக்கு மை டிவைஸ்ல போனா ஸ்பேஸ் இருக்கு 274 GB ஃப்ரீ இருக்கு ஆனா
ஓகே. ஒரு நிமிஷம் அந்த இதுக்குள்ள போங்க, ஃபோல்டருக்குள்ள போங்க.
இதோட ஃபைல் இருக்கா
இல்ல. இப்போ ஒரு ஃபோல்டர் ஓபன் பண்ணீங்களா? சி டிரைவ். ஓகே. நீங்க கொடுத்த லொகேஷன் எங்க இருக்கு? அந்த ஒர்க் ஸ்பேஸ் லொகேஷன்.
லொகேஷன் இதுல போய்
இதுல ஆக்சுவலி ஒர்க் ஸ்பேஸ்.
ஓகே நான் சேவ் பண்றது
இல்ல நீங்க ஓபன் பண்ண உடனே ஒர்க் ஸ்பேஸ் ஒன்று கொடுப்பீங்கல்ல?
அது ஓகே அது டெஸ்க்டாப்ல தான் இருக்கும்
ஓகே. சரி ஒண்ணும் இல்ல. இத க்ளோஸ் பண்ணுங்களேன்.
இதோ இருக்கு சார். ஒரு நிமிஷம் எடுத்துறேன். எங்க அது? இங்கதான் இருக்கு. இதோ இதான் இது.
சரி இது வேண்டாம். ஒண்ணே ஒண்ணு மட்டும் ட்ரை பண்ணுவோம். இத க்ளோஸ் பண்ணுங்க ஒரு நிமிஷம். இப்போ ஓப்பன் பண்ணுங்க HTML. ப்ரௌஸ்
அதான்
கிளிக் பண்ணி
யூசர்ஸ்
அது ஓகே. ப்ரௌஸ் டவுன்லோட் ஃபோல்டர் செலக்ட் பண்ணுங்களேன். லெஃப்ட் சைடில் டவுன்லோட்ஸ் இருக்கு இல்லையா? அதை செலக்ட் பண்ணி சும்மா ஒரு புதுசாக ஒரு ஃபோல்டர் கிரியேட் பண்ணுங்க. இல்லை மேலேயே நியூ ஃபோல்டர் இருக்கும் லெஃப்ட் சைடில். மேலே இல்லை நியூ ஃபோல்டர். சும்மா ஏதாச்சும் ஒரு நேம் தாங்க. ஓகே ஓப்பன். செலக்ட் ஃபோல்டர். சரி இப்போ லான்ச் கொடுங்க. ஓகே மேக்ஸிமைஸ் க்ளோஸ் ஃபைல் நியூ STM32. ஒரு நிமிஷம். Exclude STM32 cube ID from being scanned from information. Okay. Okay. சரி ஒண்ணு பண்ணுங்க. நீங்க இந்த கியூப் MX வச்சிருக்கீங்களா? நீங்க கியூப் ஐடியும் வச்சிருக்கீங்க, கியூப் MX வச்சிருக்கீங்க. சரியா?
இல்ல அது டவுன்லோட் ஆனாலே ஒன்னாதான் ஆகுது.
கியூப் MX அப்படியா? எனக்கு கியூப் MX டவுன்லோட் ஆகலையே.
அப்டேட் ஆகும்போது சேமா தான் சார் ஆச்சு. ஒரே டைம்ல தான் ஆச்சு.
சரி இந்த கியூப் MX நீங்க தனியா அன்இன்ஸ்டால் பண்ண முடியும். ஓகேவா? கியூப் MXன்றது STM கியூப் ஐடி மாதிரியே தான். ஸோ இது ஒரு தடவை அன்இன்ஸ்டால் பண்ணிட்டு செக் பண்ணி பாருங்க. ஒர்க் ஆகுதான்ட்டு. இல்லைனா வேற ஏதாவது மெத்தட் தான் ட்ரை பண்ணி பார்க்கணும். உங்ககிட்ட ஏதாவது எக்ஸ்டர்னல் பென் டிரைவ் இல்லை எக்ஸ்டர்னல் ஹார்ட் டிஸ்க் ஏதாச்சும் இருந்துச்சுன்னா அதை கனெக்ட் பண்ணி அதில் ஒர்க் ஸ்பேஸ் கிரியேட் பண்ணி செக் பண்ணி பாருங்க வருதான்ட்டு. இன்கேஸ் இதில் ஏதாச்சும் ப்ராப்ளமாக இருக்குது அப்படின்னா நம்ம எக்ஸ்டர்னல் ஹார்ட் டிஸ்கில் ஏதாவது ப்ராப்ளம் இல்லாமல் இருக்கும். அதில் வேணால் கனெக்ட் பண்ணி ஒரு செக் பண்ணி பாருங்க.
ஓகே சார்.
சரி ஓகே.
அதுதான் இது சிஸ்டம் அவங்க இதுலயும் கேட்டு பார்த்தேன். அவங்களும் 1 வீக் ஆகும்னு சொல்றாங்க ரெடி பண்றது.
ஓகே. மற்றதெல்லாம் ஒர்க் ஆகுது. இது ஒன்று மட்டும் தானே?
ஆமா. அது ஆக்சுவலா ஒரு சாஃப்ட்வேர் டவுன்லோட் பண்ண அப்பல இருந்து தான் அந்த மாதிரி ஆச்சு.
ஓகே.
RTM சாஃப்ட்வேர் ஒன்று டவுன்லோட் பண்ணி
RTM PCB டிசைன்.
ஆமா.
ஓகே.
அப்பல இருந்து தான் இந்த மாதிரி ஆயிடுச்சு. அது இத்தனைக்கும் அந்த ஃபைல் ரொம்ப பெருசா இருந்துச்சு. டெலீட் பண்ணிட்டேன். திருப்பியும் இதாக மாட்டேங்குது. லைசன்ஸ் இல்லைன்னு சொல்லி டெலீட் பண்ணிட்டேன்.
ஓகே.
இப்போ திரும்பியும் அது இது பண்ண.
சரி ஓகே. செக் பண்ணி பார்ப்பேன் என்னட்டு. நானும் வேறு ஏதாவது பார்க்குறேன். அது சிஸ்டம் ரிலேட்டட். நான் முன்னாடி சொன்ன நம்ம சிஸ்டம் ரிலேட்டட் இஷ்யூ தான். ஸோ ஃபோரமில் இருக்குமான்னு தெரியல. நான் ஃபோரமில் செக் பண்ணி பார்க்குறேன்.
ஓகே சார்.
ஓகே.
ஆல்டிஎம்க்கு ஏதாவது கிராக்டு வெர்ஷன் இருக்குமா சார்?
தெரியல. செக் பண்ணி பார்க்கணுமா? சரி. Yeah. So this is about the free RTOS. Okay, the entire module. So what we did in this entire module is like we have created a task. Okay, and then we have given the multiple priority for the task, and we saw what is preemption, what is cooperative method, and then how to control the task by giving something like an task priority set, task suspend, okay, and all these things, task delete, all these things. And then we saw how to create a timer by using free RTOS, then how to use queue to store the datas in FreeRTOS, and then this synchronization methods like semaphore. In semaphore, we saw that binary semaphore and counting semaphore, and in mutex, we saw what is mutex, how to create the shared memory synchronously. Okay, that we saw, and then how to avoid this deadlock mutex. Okay, so this is what your entire FreeRTOS module is. Okay, so the next module will be the IoT that we will start from the next Monday, that is 4th. Okay, so from tomorrow, what you will do is tomorrow morning or by afternoon, mostly I'll send in morning. I'll send you the project of your C++. Okay, so what are the projects set to submit? Okay, I'll send the project of C++, pick device driver and RTOS. Okay, most probably this device driver and RTOS will be the same project, like a single project. You have to combine both those device driver and RTOS. That way I will give something like that. And then you will have a bare metal pick. This has to be done by using the RTOS, and your C++ has to be done in the same this code blocks or whatever you are using. Okay, so mostly 3 or 4 projects. Okay, and from tomorrow you have to start working. I want you to submit all these 4 projects by how many days you require? You guys give the deadline. I'll give tomorrow, that is 29th of July. When can you able to submit?
Sir, how much time it will take for a project like for RTOS and device driver?
That is simple.
Okay.
So I'll give some multi-priority projects only. Okay. It'll take some, if you can't, okay, I'll just say in hours instead of days. Okay, it will take something like some 5 to 6 hours. For this device driver and RTOS.
Okay, sir.
Yeah.
Sir,
So tell me.
C++, I not attend. Started from bare metal. So for
Okay.
C++ programming, which softwares are using, like
Code blocks
VS
will be
Code
using.
or Linux?
No, code blocks.
Sir?
Code blocks. We'll be using GCC compiler only.
GCC.
Yeah.
Okay.
So,
Okay, sir.
okay. So for you, this is also not applicable, right? I just forgot. Okay. And for Euroj also, this is not applicable. You both joined from bare metal only. Okay. So you don't need to submit the C++ project. Arvind and Euroj submit bare metal, device driver and RTOS. Okay. Others,
Yes,
you have to submit C++, bare metal, device driver and RTOS. Okay.
Possible, I also try, sir. If I
Okay.
done
Try
all
You can
sir.
try.
C++.
Anyhow, I'll send the question in, I'll send the project title in the group. Okay, you can select any one of the project. Yeah, that I'll say. So
I'll
your
do
projects.
it on G++,
Okay.
I mean G++.
Oh, okay.
On Linux, WS.
Linux, okay. Yeah. So each project title will contains, or each project module will contains 4 or 5 different project titles. For example, if you take C, in C, you will get 4 or 5 project titles. You can select any one from that. That is your wish. Okay. Similarly, for bare metal, you'll have some 4 to 5 projects, and device driver and RTOS will be having 4 to 5. You can select any one. You can start working on that. And if it is bare metal programming, you need to submit the the simulation, Proteus simulation screenshot. Okay, and then the .c file. And for C++, this .c++ file, and whatever the extra things you have the same. And for device driver and RTOS also the same thing, like the entire folder. Okay, just upload that entire content in the GitHub and then share me the link. So that is enough. And from tomorrow I'll be joining, or I'll be available in the call. Okay, if you have any doubts regarding this project, you can join in and you can clarify that and you can leave it. Okay, it is not compulsory to attend the class from tomorrow. That is this week. Okay, from 29 to 1. If you have any doubts regarding any of this project, you can join in the session and you can clarify the doubt. Okay, so that is so we'll start IoT from 4th. So I want you people to give the deadline for the project for all these 4 projects. When can you able to finish? Can you have deadline on 10 for all 4 projects? Is it fine? Like you'll be having 2 weeks, 2 entire weeks.
Okay, sir. We will try.
Sir, we'll try, sir.
Okay.
Yeah.
Okay. Just try to submit by 10. Okay. See, every day the same class timing 7 to 9 means you will have something like 1, 2, 3, 4, 5, sorry, 4, 5, 6, 7, 8, 9.
Sir, 15, 16, 17 is holiday. So after that is possible.
So that's actually 3 weeks of time. Okay. No, see, what will happen is I'll be starting the IoT from 4th, right? So I will complete the IoT by 9th or 16th. So it will add it again. So that's what
9 is a Saturday.
Sorry,
8
8th
or
or 15th. Mostly
15
15
also
the
there's
best
a
time.
class.
15th will be holiday, so I'll be finishing by 14th.
Okay.
Okay, so again that will add in the pipeline, right, for you to complete it. So that's why I thought if you finish by 10th, I'll give this by 14th, the other project.
Because
what I-
due to college work also the time will be collapsed, sir. So only
Okay.
because these
Okay, I'll
class
do
hours
one thing. Before I finish this IoT module, I want you to submit it.
Okay, sir.
Okay.
Yeah. So that
IoT means we are going to use ESP, sir.
both ESP and Raspberry Pi. By
Also?
using ESP, we will send the data to ThinkSpeak. By using Raspberry Pi, we will send the data to AWS IoT Core.
Oh.
Okay,
Raspberry Pi itself inbuilt Wi-Fi have no, sir?
Yeah, it has an inbuilt Wi-Fi.
Then why we want to go for ESP, sir?
See, ESP, we just want to see both the things. Like ESP
Okay.
will be writing .c file, and in Raspberry Pi will be writing a Python code.
Okay. Yeah.
Okay. Yeah. So we'll see how to get a data in both this, and we'll be using different platforms. Okay, ESP with the ThinkSpeak and Raspberry Pi with the AWS IoT Core.
Okay.
So Python we need to know, sir? Or
It's a basic. If you know C, then Python is nothing like. It will be having the same syntax. Okay. Yeah. Anyhow, I'll explain the code.
Okay.
Yeah. Okay, guys. So see you on 4th of Monday, 4th of July. Sorry, August. Okay. And if you have any doubts regarding the project, you can join on any of these 4 days. Okay, or else we will see you on 4th.
Okay, sir.
Yeah. If I'm not available in the call, just ping me in the WhatsApp. Okay, I'll join. Okay, guys. So thank you. I'll send the project by tomorrow morning. Right?
Okay, thank you, sir.
Thank you. Bye.
Thank you, sir.
Thank you. Bye.
Thank you.
Thank you. Bye.